while the one with the thermal break will stop exactly at the polyimide strips, not allowing the energy to go through. The same on the hot side with the chocolate. You will see the one with the normal aluminum will melt, while the thermal break one will not, because the heat is not transferring through. Of course, we have formulas to calculate the U value of a window, but there are also softwares which are doing that. And we use these softwares. This is one of the services that we offer at Technoform for our customers to measure the U valuation of their systems so that they know how efficient this window is and what are the things they can do to optimize this insulation. So as I said, you can do that through calculation or through numeric systems, and also through a real lab test, which is a hot box test. We have a hot box of our own in our lab in Germany. It's an accredited and certified lab. The results are accredited. And here you can actually measure a real live window and know the U value exactly of this window system. But the softwares which also calculate this kind of U values are also very precise. We have between 96 and 97% exactitude of the software calculated U value versus the actual hotbox test. So they are quite precise. These are some of the ones which are we use, and you can use also. Some of them are free and downloadable from the internet, like Therm, and then there is Bisco, Flixo in ISO. These are all softwares which you can use. This is the kind of result that you will get from such a study. It will give you the isothermic lines of the flow of energy. And you can see the blue side, of course, is the cold side. So if you place a temperature of 0 degrees outside and 20 degrees inside, you will see what's the approximate measure of the temperature here. It's around 18 from the inside. This is a good way to measure your window before you even construct it, before you even extrude it. So you can do this on a computer-based software. These are just to compare. On the left, you have a non-thermal window, and you can see how the cold is coming in, and it's almost all blue. And on the right, a similar one with thermal break, how it stops really at the level of the double glazing and the thermal break, the flow of the energy. Some other systems, this is a sliding system. For the curtain walls, it's a completely different formula, but again, don't be scared by the formula. You have the software, which is calculating the UTJ. It's the U value of the thermal joint. Because curtain walls, and especially structural curtain walls, are mostly all glass from the outside, so there is no real aluminum showing from the outside. The calculation here is done by the UTJ. That means you calculate the U value of the thermal joint, which is in the center between the glass and the aluminum. It's another formula, but it will also give you ultimately the U value of your facade. Some examples of the results you get with the facades. And just to give you some examples, what makes a better or a worse window system? You have some basic systems. Here you have a normal. You can see the thermal break in the middle where the 18 millimeter is. It's a flat-shaped 18 millimeter strip. And here the U value is measured with you can see there W per square meter Kelvin. This is watts per square meter Kelvin. And here you have about UF, that means the U value of the frame, excluding the glass, because we are interested about the frame. The glass, you will get the U value of the glass, the UG, from your glass manufacturer. And here you can see you have a 3.5 watt. If you have a better system, and you can see here the central gasket, for example, is sitting on polyimide and closing to polyimide, so this is an enhancement.